All right, so this is the thinking review questions related to sodium reabsorption and potassium excretion in the kidneys. It's important for you to make sure that you do these ahead of time so you have good practice to make sure you understand them. But again, here is the pathway, and here are the questions, and I've listed the question here along with the what happens with sodium reabsorption, potassium excretion, and then the rationale. So the first is, what happens when you have an increase in angiotensin II? Well, if you have an increase in angiotensin II, that's going to upregulate the sodium hydrogen exchanger 3, step number 3 here. More sodium then would enter the renal tubular cell wall, and therefore more would be available to be taken up via the sodium pump. And at the same time, sodium entering the blood, potassium would be removed and eventually taken up into lumen. So the idea here, this would increase the amount of sodium being taken up by the renal tubular cell wall and eventually be made into the sodium pump. And as the sodium pump is moving sodium into the capillaries, it's also removing potassium. So you'd have an increased reabsorption of sodium and increased excretion of potassium. What about decreased aldosterone? You decrease the amount of aldosterone, that's going to decrease sodium reabsorption and excretion because you would have less activation of the sodium chloride co-transporter, and therefore less sodium would be taken up into the renal tubular cell wall, and less sodium would be taken up through the sodium pump and made its way into the capillary blood. Likewise, less sodium taken up would mean less removal of potassium out of the capillary blood. What about decrease in salt intake? Well, decrease in salt intake would reduce the sympathetic activity and the angiotensin II, and this is going to then decrease the sodium hydrogen exchanger 3. And so steps 3 and 4 would be reduced, less sodium would be taken up by the into the renal tubular cell wall. Also, with the reduction in sodium, it would also reduce the amount of the sodium pump that would be activated. Also, it would reduce the amount of digitalis-like factor that would be made, all of which would reduce the amount of activation of the sodium pump, and therefore less sodium would be taken up into the capillary blood, and likewise less potassium would leave the capillary blood, and eventually less would make its way into the tubular lumen. Therefore, you have a decrease in sodium reabsorption and a decrease in potassium excretion. What about increasing fruits and vegetables in our diet? That would decrease sodium reabsorption and also decrease sodium or potassium excretion. And the reason for that is an increase in fruits and vegetables would decrease sodium in your diet, which would reduce the sympathetic activity response, reducing epinephrine and angiotensin II, which would reduce the amount of the sodium hydrogen exchanger 3 activity, and therefore less sodium would make its way into the renal tubular cell wall. Therefore, less would be available in the sodium pump to be activated to move sodium into the capillary blood. And also you'd have, without sodium moving into the capillary blood and the reduction of the sodium pump, less potassium would leave the capillary blood and make its way into lumen. So you'd have a decreased reabsorption of sodium and also a decrease in potassium excretion. What about a decrease in digitalis-like factor? Well, a decrease in digitalis-like factor would slow the sodium pump, and therefore it would allow less sodium pump activity, would prevent the sodium from being taken up into the capillary blood from the renal tubular cell wall. At the same time, less potassium would leave the capillary blood. So less sodium would be reabsorbed and less potassium would be excreted because the sodium pump would be downregulated due to a reduction in the digitalis-like factor. All right, so make sure that you go over these thinking review questions, having a good understanding of them. If you need to review the video or review the slides, I'll post these up on Blackboard as well.